Here we look at building a polynomial if we know information about its zeros. Here we are going to see multiplicity. We're going to see an irrational zero, and we're not going to specify the degree of the polynomial that we're trying to determine. In fact, the directions say determine a polynomial of smallest degree. Okay, so we have to know what degree our answer should be in. So let's see what we can figure out here. 0 is a 0. It has multiplicity 2. That means that x minus 0, or just x if you simplify that, is a factor, right? Zeros give us factors, so x is a factor 2 times, which means we have x times x, or x squared, because factors multiply together. So we know x squared is one of our factors. So our goal here is to turn each of these zeros into factors and then use those factors to build a polynomial. We're trying to create variables here because a polynomial has variables, has x, okay? Alright, then we know that negative 1 is a 0, multiplicity 1. That means that x minus negative 1, or more simply x plus 1, is a factor 1 time. So that means we have x plus 1 to the first power is a factor, okay, or just x plus 1 if you want. Finally, we know 1 minus the square root of 2 is a 0. It doesn't tell us its multiplicity, so let's keep it multiplicity 1, because we want the smallest degree, okay? Multiplicity 1. Now, there are two things that we can conclude from this. One is the obvious, that x minus that is a factor. Or, if you distribute the negative, which I would like to do, that'd be x minus 1 plus the square root of 2 is a factor. 1 time is a factor 1 time. So that gives us x minus 1 plus the square root of 2 to the first power. Okay? But it also tells us something else. It tells us that since this is irrational zeros come in conjugate pairs. Should know that. Since 1 minus the square root of 2 is a 0, it has to be true that 1 plus the square root of 2 is a 0. And since this is multiplicity 1, this also has to be of multiplicity 1. Okay? Now we have to know that. Nowhere in this problem does it tell us that 1 plus square root of 2 is a 0. You have to know that. And now we know that we can turn that into a factor. X minus 1 plus the square root of 2 is a factor, or x minus, if you distribute the negative, which will be helpful, x minus 1 minus the square root of 2 is a factor, of course 1 time. So x minus 1 minus the square root of 2. So we have x squared is a factor, x plus 1 is a factor, x minus 1 plus the square root of 2 is a factor, and x minus 1 minus the square root of 2 is a factor, and of course 1 time. Now we just need to multiply all those together. So we build the polynomial by multiplying, because you always multiply factors. Okay, so that's what we're going to do next. So we have x squared times x plus 1 to the first times x minus 1 plus the square root of 2 to the first times x minus 1 minus the square root of 2 to the first. And of course we could adjust the constant coefficient out here in front if we need to. But for now let's multiply out what we have. I recommend always multiply conjugates first. If you don't, it gets really messy. It gets kind of messy anyway, but it gets really messy if you don't do that first. So what we have here is x squared times x plus 1, and then I've got to distribute all of this. So x times x is x squared, x times negative 1 is negative x, x times negative square root of 2 is negative square root of 2x. Then I distribute my negative 1. I get negative x. I get positive 1. And I get positive square root of 2. Lastly, I distribute my square root of 2. So I get positive square root of 2x minus square root of 2. And square root of 2 times square root of 2 is square root of 4, which is the same thing as 2. And I've got a positive times a negative. So I get negative square root of 4 or negative just 2, because the square root of 4 is 2. And I've got all that when I multiply those two trinomials together. Now I'm going to simplify it. I'm just going to carry down the beginning stuff. So the only x squared term I have is x squared. Then I've got negative x, that's negative 2x. Then I've got negative square root of 2x plus square root of 2x. That's 0, so those go away. I've already dealt with my negative x here. Let's cross these out as I finish. I've already got my x squared, negative x and negative x I've got, negative square root of 2x, positive square root of 2x I've got. Then I've got plus 1, minus 2 gives me minus 1. So those go away. And I've got positive square root of 2, negative square root of 2, that's 0. So I don't have to write that down at all. So see how nice and simple this cleans up? So multiplying the conjugates first always cleans up nicely. If it doesn't, you made a mistake somewhere. Okay? Now, I'm going to save my x squared till the end because it's the easiest part to multiply. Now I'm going to take this binomial by this trinomial. So I'll copy my x squared. I get x cubed minus 2x squared minus x. Then I get plus x squared minus 2x minus 1. And let's clean that up. So I get x cubed, negative 2x squared, positive 1x squared gives me negative 1x squared, or just negative x squared. Negative 1x, negative 2x gives me negative 3x, and minus 1. And we are almost done. Now I just need to distribute my x squared, so I get x to the 5th, minus x to the 4th, minus 3x to the 3rd, minus 1x squared, or just x squared, and it actually cleaned up very, very nicely to give us this degree 5 polynomial. So smallest degree had to be degree 5 in this particular problem, because I had to have x squared, because multiplicity 2, I had to have x plus 1 to the first, I couldn't go any less than that, and I had to have both of these to the first, and I had to guarantee that 1 plus the square root of 2 was a 0, because it's the conjugate of this given irrational 0. So I built a polynomial, degree 5 polynomial, and it has the zeros that were described above.